Hello everyone, we are Team Monks and we have worked on predictive algorithm. How much time do we really have? There is no way to know for sure, but here is how we can see the road ahead. So the problem we have worked on is to predict the number of positive cases in the USA between July 27 to August 15, that is in the span of 20 days. As you all are familiar with COVID-19, is an infectious disease caused by the recent formed virus known as coronavirus. As per the US stats, COVID-19 is about 2.5 million coronavirus cases. The USA has the highest number of confirmed cases in the world. So, in order to predict the future cases, we have performed some actions such as data gathering, pre-processing, visualization, analysis and prediction, and forecasting. The dataset we have worked on here is a collection from various sources like New York Times, GitHub, and it contains attributes such as date, county, FIPS, cases, and with around 363,000 observations. Let me walk you through the data. Here is the data we have plotted against regions and the cases, with Midwest being the highest and Northeast being the lowest. While coming to the county wise, Washington being the highest and McTown being the lowest, and states versus cases with Texas has the highest number of cases and District of Columbia has the lowest number of cases. So you'll be wondering, why do we need a new model in spite of having many existing models? But these models have some drawbacks, like linear regression can only work with linear data, and a support vector machine needs a lot of parameters. So a model and rich model assumes the current inventions will remain unchanged during the forecasted period, and the profit model will only best fit with the time series that have strong seasonal effects. So while working through our solution, we have built an RNN model. We have defined a class called RNN, specified parameters, input size, output size, hidden dimensions, and end layers. We have generated evenly spaced test data points with about 30% size. Then we initialized an RNN after tuning its hyperparameters a little, and we chose a mean square error loss and Adam optimization with a learning rate of 0.01. So you'll be thinking, why this model? The benefits of this are RNN model. It can only add the explicit handling of order between observations when learning a mapping function from inputs to outputs. The addition of the sequence is a new dimensions to the function being appropriated. Instead of mapping inputs to outputs alone, the network is capable of learning a mapping function for the inputs over the time of output. So we have trained this model in such a way that the red line indicates the original number of cases and the blue line indicates the predicted values. Now when we have tested our model and predicted for the next 20 days, this graph is obtained with, we can see that it predicts the curve should be less deeper than the current flow of the graph. So since the model predicts for the next few days, it will be much accurate compared to the other models. The hospitals and quarantine community would be most benefited with this because they can be well prepared for the upcoming cases. In near future, we are going to implement an interface to our model so any user can have easy access to it. Here is our team. We all together contributed in developing this model. I would like to thank Mr. Vail and Ms. Fatima in guiding us to successfully build this model. A very special thanks to Steve and Hackmakers in arranging this event. Thank you.